Hello everybody, we're going to be looking at rigid motion a little bit more today with a focus on congruent figures. We're going to be looking at translating, reflecting, and rotating on a coordinate grid. Our hope is that when you are watching this video and this Edpuzzle, you'll then be using this as a guide to help you through some of the problems. There will be a few that you'll try on your own. There will be an answer key also in the document for you to check as we go. But we're going to be focusing now on using these in a coordinate grid, focusing on the different types of rigid motions, and if the two-dimensional figure is mapped to its image through a sequence of rigid motions, the figures are congruent. Remember what congruent means. It means the shapes and the size stay the same. We change its location and orientation, but nothing else about it changes. So if I see triangle ABC and triangle XYZ, I would say that it is congruent. This is the symbol for congruency. So in mapping two shapes on a coordinate grid, one of the things that we're going to look for is matching them up by the triangle name. In this situation, we have triangle A, triangle ABC, and triangle EFG. A matches up with E, B matches up with F, and G matches up with C. Okay, and when we're trying to map them to show that they are congruent, we want to make sure that we line up both of those triangles in the correct order. Okay, ABC would be considered our pre-image, where EFG would become the image. When solving a problem like this and describing a series of rigid motions that would prove that ABC and EFG are congruent, we're going to really need to make sure that our letters line up. So if we made a focus on letter A and letter E, we'd have to make sure that those two would cross over each other perfectly. So one way to do this is I could start by reflecting over the y-axis. Remember, when we reflect over the y-axis, every point has to be equal distant from the original and that axis. So A would be 2 over, so A prime would be over here on that side. B is over 4 on the x-axis, so B would have to be negative 4 on the x-axis on the reflection. And C is also at 4, 4, so we would do that at negative 4, 4. This would allow us to have a reflection that would put A in the correct spot, B in the correct spot, and C in the correct spot in relationship to EFG. Now, we'd have to ask ourselves, well, how would I get those to fit? So we might have to slide over 1 on the X, and then it looks like once we slide over on the X, we're going to slide down 3 on the Y. So if I'm thinking about that in terms of a rule, all right, we'll talk about that in a second. So we're going to move it over, and we're going to describe it in a series of events. So I might say step 1, reflect triangle EFG over the y-axis. Step 2, I'm going to translate. How am I going to translate this? Well, I've got to move it over on the x1, so it would be x plus 1, and then I move it down 3 on the y, so it'd be y minus 3. Example number 2, we're going to describe a series of rigid motions that proves that rectangle ABCD is congruent to rectangle WXYZ. If you notice that point A and point W are not located on the same part of the rectangle, though they are, what we need to do is prove that those 2 points will line up. So translating just to the right and down will not work, okay, because we have to have A fit where W is. So what we're going to do is, even though we could probably rotate this, we're going to reflect it as an example. Okay, the first thing we're going to do is we're going to rotate over the y-axis. Okay, so we're going to reflect A, B, C, D over the y-axis. Okay, and if that's the situation, every point has to be the same distance away from that reflection point. So we have here would be B prime, we would have A prime, D prime, and C prime. And it would map out to look like this. Perfect mirror image. Okay, now we got to be careful here. On the next step, we're going to reflect as well. Over the x-axis, but the x-axis isn't at the original x-axis point. We're going to draw a new line of reflection, kind of like we did with transformational golf right here. We would consider that line as x is equal to -1. And as you can see, then if we reflect that, A prime would go right over to where W is, and we would be able to prove that they are congruent. Please try numbers 1 and number 2 by describing a series of rigid motions that prove that rectangle and those triangles to be congruent. Check your answers with the answer key found in the folder. Students who are looking for a little bit of a challenge, you'll see that we have challenge 1 and challenge number 2. Again, these are not things that are required for all to do, but for those people that want to push themselves a little bit further, you have 2 examples here that would be wonderful for you to try. Again, the answers will be found in the answer key found in the folder. And if you have any questions, make sure you let me know. On page 8, we're going to start working on some translations. Okay, remember translations are slides, and the goal is to be able to show through the coordinate grid your new image of triangle JKL. If we are to follow the rule for x and y in our translation from one point to the other, the goal is to make sure that first we map what we know. Okay, we're going to work on translations right now using a rule. We're going to make sure we graph it on our coordinate grid. We are having our preimage of JKL. We want to create its image of J prime, K prime, L prime using a series of rules. So how do we get J prime is 0, 3? Well, we're going to use the rule that x plus 4, y plus 2, when applied to the original coordinates, is going to give us 0, 3. So let's go and check it out. So we have x plus 4. Okay. In our situation, J is -4. So -4 plus 4 is equal to 0. So now we know that x is equal to 0. Okay, let's try the y. We know that it's y plus 2. We know that the y for j was 1. So we could say 1 plus 2 is equal to 3. So we now know that y is 3. Now if we apply that to the other two, we'll be able to get our other images. But first we want to make sure we plot j prime. So j prime would be at 0, 3. Now let's start with k. Same rule. We have x plus 4. Okay, -2 is our x, so that would be -2 plus 4 would be 2. So we now have an x that is 2. Let's go. We have y plus 2. We have that the y is -2. So -2 plus 2 is equal to 0. So we now know that the second coordinate is 2, 0 for k prime. So we're going to go over 2, up 0, and we're going to label that k prime. Now, the last one, L. L, 1, 2. Same idea. X plus 4 is the rule. We know that x is 1, so 1 plus 4 equals 5. Our x is 5. We have y plus 2. 2 plus 2 is equal to 4. So now we have a coordinate of 5, 4. And we're going to mark that as L prime. So over 5, up 4. And that's L prime. Once we have that, we have L prime. We're going to connect those dots. And we've created our congruent figure to the original pre-image. Once that is done, we can say that the image is congruent and that we can use the symbol of triangle JKL is congruent to triangle J prime, K prime, L prime. In the next two translation problems, you're going to see that they're telling you how far to translate your pre-image into your image. So they're saying that you're going to be moving 5 units to the right and 1 unit up. So the rule for that would be x plus 5 because I'm going to the right, y plus 1 because you're moving 1 unit up, okay, no matter where your starting point is. For translation, the second problem, you're moving 1 unit to the left. Anytime I move to the left, I'm subtracting, and if I'm moving up, that means I am adding. And you're going to use these rules to help you map the new image onto the grid. We're looking at the next types of translations. We're trying to figure out what's happening to each of our coordinates. So, map this out here. If we look at Z, we're moving over to the right 2 and down 1. For K, you're moving over 2, down 1 to K prime. For I, you're moving over 2, down 1. So in a situation like this, the rule would be X plus 2, because it's going to the right, Y minus 1, because you're going down 1. For number 6, again, we're going to be starting with our pre-image, which is V, and we're going to be moving to V prime, which is our image. So what we see happening is we're moving 1 to the left and up 1. T, we're moving over to the left 1, up 1 for T prime. From I, over 1 to the left, up 1. So what we can see in the situation, our X is decreasing by 1, but our Y is increasing by 1. We're going to be working in class on the rules of rotation a little bit more this week because this is the one that's the most confusing. So there are certain rules that we can abide by when it comes to rotating 90 degrees, 180 degrees, or 270 degrees. When I'm rotating 90 degrees, what's going to happen is my coordinates are going to reverse. My Y becomes my X, and it's going to become negative, and my X becomes my Y, and it stays positive. So if I'm dealing with 3, 5 as my pre-image, my new image will make the first X be 5 and make it negative because I'm going to be switching my Y's to my X. And then my X becomes my Y at 5, negative 3. And I'm going to map it over on that side. So for 2, 3, my Y is 3. The opposite of Y, which is the opposite of 3, is negative 3. And X would be 2. For C, the opposite of Y, which is 1, is negative 1. And my X is 4. The rules for 180 are a little bit different. If I'm going 180 degrees, my X becomes negative and my Y becomes negative. So the opposite of X in this situation would be negative 3 because A was 3. The opposite of 5 is negative 5. The opposite of 2 is negative 2. The opposite of 3 is negative 3. The opposite of 4 is negative 4. The opposite of 1 is negative 1. And again, I'm going to map it over here. Try to choose a different color for each of your mappings. So that would be for A double prime, B double prime, and C double prime. The last one is 270 degrees. In this situation, the Y becomes the X, but it remains positive. My X becomes the Y, and it becomes negative. So Y is 5. The 3, the opposite of X, which is 3, is negative 3. For B, Y is 3, which becomes our X. The opposite of 2 is negative 2. C, the Y is 1. The opposite of 4 is negative 4. And that becomes my new coordinates. I hope this gets you guys started with some of the problems for the week. Again, if you have questions, you need to reach out to me during the study center time, period 5, or email me throughout the week. Thank you so much. Have a great day.